Great. So I'm Theresa Harbig, and thank you for staying for the very last talk about the visualization of longitudinal cancer genomics data. So first about cancer. As you probably know, cancer development is an evolutionary process, and it is characterized by random mutations and natural selection. And because of these random mutations, even cancers of the same type can have very different mutational patterns. So, and in the most ideal case, we want to use these mutational patterns to predict the influence of a treatment on tumor, because these patterns influence how and if a treatment works. So we're not there yet, but there are some visualizations out there which visualize cancer development. And this is a fish plot, and it visualizes the development of a cancer for one patient. But we need visualizations for entire patient cohorts because we want to explore more general temporal patterns and not only patterns for one patient. So this leads us to the requirements for our tool. So we want to develop a tool for the visualization of temporal cancer genomics data in patient cohorts. And it should be able to integrate multiple different data types. So not only mutation data, but also expression data or protein measurements. So whatever you can measure about your sample. And it should be web-based, and it should be compatible with the CBio portal. And the CBio portal is a portal for cancer researchers where they can analyze their clinical trials and studies. And so far, it's missing the temporal visualizations, and we want to provide that. And so far, we're using the API of the CBio portal for our visualization. So to come up with the first idea for our tool and to create a shared vision for our team, we tried a new technique called a design sprint. And it is usually not applied to visualization problems. It's developed by Google. And in this technique, you basically come up with a tested prototype in only 5 days. So you start defining your goal and interviewing users on Monday. And on Tuesday, you start sketching. On Wednesday, you decide for the best sketch. And you basically implement a simple prototype with this sketch on Thursday. So you do that with Keynote or PowerPoint slides, so there's no real programming involved. And on Friday, you take this prototype and you test it with potential end users. So based on this prototype and the feedback we received for it, we developed our tool called OncoThreads. So before I show you how we visualize an entire cohort, I'll just show it for one patient. So imagine you have one patient and you have 2 samples at 2 different time points. And you chose to look at the neoplasm histologic rate, so how progressed is the cancer. And you also look at the mutation count, which is the sum of all mutations. And for this patient, you can see that the grade is much higher in the second sample, and also the mutation count is very high. This is actually called hypermutation. So now the question is this just the natural progression of the cancer, or was there maybe some external factor influencing that development? So maybe the patient received a treatment between these 2 samples. That's why we implemented the possibility to add treatment blocks between these sample blocks. And when we do that, we can see that the patient received a drug called TMZ, which is temozolomide. It is a chemotherapy between the 2 samples. So of course, from one patient, we cannot tell if TMZ caused this high mutation count. So we have to check if this is a common pattern. And this brings us to the first screenshot of our application. So it's basically the same as before. We just have more patients, and each column corresponds to one patient. And it's basically a temporal heat map where time flows from top to bottom. And now we want to see if there are many patients who receive TMZ and have a high mutation count. And if we go through it column by column, we actually find 5 patients for which this is the case. But this is not very convenient. So we don't want to go through it column by column. We want to have an easier way to see it. So how can we make that pattern easier to see? To do that, we developed 2 possibilities, which are sorting and grouping. And in sorting, you can basically sort each block independently, so each sample or treatment block, and you can apply the sorting to the entire heat map. So we'll see this here. So we sort after mutation count, and we applied it to the entire heat map, and then all the patients with TMZ and a high mutation count are on the right, here. And the other possibility is grouping. So in grouping, we no longer want to look at single patients, we want to look at proportions of patients. So for example, we want to look at the proportions of patients who have a high mutation count and a low mutation count. And mutation count is a number, so we have to create these categories ourselves by binning, which you will see in the beginning of the video. And then you will also see what happens when we group the other blocks too. So first we bin mutation count, and then we have two categories, high and low. We group the other blocks, and we created a Sankey diagram. So in the Sankey diagram, the flows show you how many patients move from one state to the other. So you can see here that a big flow from TMZ goes to high mutation count. So the entire way we make these connections, so the connections with these flows and the connections with lines, and also how we sort and group, is inspired by the Domino technique. In the Domino technique, you can create multiple connected visualizations. And if we zoom in here, it actually looks quite similar to our tool. So Domino is quite general, and our tool is a little bit more specific. An example for that is the timeline we developed. So back to our problem. Imagine you want to find out if the treatment length had an influence on the mutation count. So from this plot, you cannot see it because it only gives you true or false values for the TMZ treatment. But if we switch to a global timeline by pressing a button, we can see when exactly the samples were taken and when the treatments happened and how long the treatments were. So as a summary, temporal cancer genomics data can be visualized using temporal heat maps and Sankey diagrams, and also timelines. And the tool Domino inspired our design choices, like the way we make connections and how we sort and group. And all in all, the design sprint technique helped us to develop a new concept within only 5 days. We still have to evaluate it, but we think it might be a good starting point for other projects too. So thank you, and thank you also to my design sprint team, and you can see us at the poster B763.
Thanks very much. So, who has a question for Theresa? Yes, please. Thank you.
Hi.
Thanks for the talk. It was great. So I just have a question. So if you look at those fish plots,
Yes.
they actually show you the composition of a tumor
Yeah.
in terms of the different clones. So I was wondering if there's if you have any thoughts on how to incorporate that kind of information in your visualization.
So the problem is we can only show one square per sample, but we might integrate a view where you can click on the patients and get a more detailed view about the clonal evolution too.
Got it. Thank you.
Okay, if everyone is happy, thanks very much again, Theresa, for an excellent